Welcome to clickmyproject.com. Let me discuss about the process row resolution phase tracker robust to illumination variations. Let me see the abstract of the process. Detecting the face from camera may be affected by some uncontrolled illuminations. Due to this effect, low resolution faces may be acquired. Although the face tracking in the video is ineffective due to the low resolution faces which contains limited information, and there may be illumination on small region of the faces. To overcome this problem, we use gradient logarithmic field because it is effective in tracking the low resolution faces. In many video surveillance applications, the faces is acquired by cameras are ineffective due to the low resolution faces and uncontrolled illuminations. These problems may be overcome by using gradient logarithmic field (GLF). GLF is the global feature model and it is effective in tracking low resolution videos. GLF based tracker works well on illumination changes and outperforms many state-of-the-art tracking algorithms. In the performances, we plot the graphs for error of the tracking results. We propose an evaluated GLF tracker to address the problem of tracking a low resolution face subjects to the illumination changes. The GLF features mainly depends on the intrinsic characteristics of a face and is only marginally affected by the lighting source. In addition, the GLF features is a global feature and does not depend on the specific face model, and thus it is effective in tracking low resolution faces. The experimental results shows that the proposed GLF based tracker works well under significant illumination changes and outperforms many of the state-of-the-art tracking algorithms. Let me see the flow of the process. In this process, the input video that contains the face images were taken. So the input video must have the face images more clearly obtained. After the detection of the videos were converted into frames. The conversion of the video into frames were done based on the identification of the height and width of the video frames and the total number of frames in the video sequences. After that, the pre-processing steps were employed, which is done based on the filtering processes applied to the images in order to overcome the intensity differences in all over the images. After that, the detection of the face regions were employed based on the MATLAB operator for face detection, and using that MATLAB operator, the face regions in the images were detected, and these detected regions were chosen as the initialization for the further face tracking processes. After that, the gradient calculation and the histogram calculation were done based on the identification of the texture structures and the intensity differences all over the video frames. So using gradient calculation, the texture structures were obtained, and using histogram calculation, the overall intensity changes were obtained, and finally the head sequences were tracked with the help of the GLF algorithm, in each time estimating the head position compared with the previous position, and based on that the tracking is applied all over the video frames. Finally, the performances of the processes were measured in terms of the error rate and the other processes for the analysis of the steps. Finally, overall, the video frames, the face regions were tracked and the overall performances of the processes were measured. Let me see the running procedure of the process. If you want to run the code, select the file main.1.m, which is located in the source code folder. Right click and click on run. The process will get started. This process is developed in MATLAB 2013 version, and please run the process in MATLAB 2013 version, and also the process will work for the videos that is given in the datasets. First, select a video from the dataset. So as we have selected, the video will be loaded and it will be displayed here. The video will be played here. After that, we select the frame conversion process. So in the frame conversion process, the videos were converted into frames and the results were displayed here. After the frame conversion process, we move on to the pre-processing process. So in the pre-processing process, the pre-processed filters were displayed here. Here, three different types of filters were employed for the pre-processing of the videos in the datasets. So the process will done based on the Gaussian filter, adaptive filter, and the normal filter. Then after the process is run, the next window will be opened. After the filtering process has been completed, the next window will be opened. First, the face in the input image is detected. After the detection of the face, the further processes for the continuous tracking of the face images were employed. First, this is the detected face regions in the input images. So we mask the face region in the input images. So this masking is done by the manual cropping of the exact image portions in the images. So the masking is done. After that, the gradient map is calculated. So the edge regions and the overall texture synthesis were done based on this, and after that the tracking process is employed. So as we can see, based on the first initial position detected, the complete face sequences were tracked. After that, the overall performances of the processes were measured in terms of the comparison of the methodologies that we have used for the process. Thus, we have continuously tracked the face images in the regions, and also we have identified the overall performance of the processes. Thank you.